as we get started today, I want you to start with a classwork problem. Go ahead and graph x squared equals negative 12y. If you happen to use two different Cartesian planes in your homework last night, probably have room on one of them to squeeze that in. If you've already got four parabolas all in the same Cartesian plane already, don't squeeze a fifth one in there, for heaven's sakes, make a new one. But pause the video for a moment while you graph this, and then we'll get started. All right, well, my students are super fast. They're already done with this one. So let's go and take a look at the classwork, and then we'll look at the homework. Graphing x squared equals negative 12y. The first thing we've got to identify about, well, first of all, we need to identify it is a parabola. How do we know?
Only one squared.
Only the one is squared, the other's not. It's already in parabolic form, but where is the vertex of this parabola?
0.
Right, if there was something added or subtracted with the x and then squared, or if there was something grouped with the y added or subtracted, that would translate or shift the vertex, but the vertex is still at 0, 0. Next thing we need to determine is which is the
Axis of symmetry.
axis of symmetry, and which one is this time, Jamie?
Y.
How do we know it's the y-axis?
It's not squared.
It's the one that's not squared. Then we need to find the focal length. Remember, the parabola is defined as the locus of points equidistant from a given point called the focus, given line called the directrix, on the y-axis from the vertex. We need to measure how far back, or I guess up or down, in this case since it's y-axis, we would need to go to the focus, and how far?
Down 3.
Down 3 to the focus. And then, by the way, if we go down 3 to the focus, that means we're going to have to go
Up 3 for the directrix.
up 3 to the directrix, good. And then we're going to find the half lattice rectum lengths. Again, the whole lattice rectum we could find as well, but for the graphing purposes, it's easier to think in terms of halves. How big is each side of the lattice rectum, Jamie?
6.
6. So we're going to stay here on my y-axis, which is my axis of symmetry. The vertex is going to be here at 0, 0, but we're going to go down 3 to the focus. Up 3 gives us the directrix. Then from the focus, we're going to go out 6 in each direction for a total length of the 12 that we see here for the lattice rectum, and then a very gradual curve, very wide parabola. And always fun to graph the really wide ones. Something along those lines is what we should have had. Did we get that for our parabola? All right, questions at all on the classwork? All right, let's take a look at the homework where you did number 9, A, C, E, and G. And I didn't mean to erase the word vertex because I'm lazy and didn't want to have to write it again. Vertex. There we go. Still there. All right. And number 9A, we're on page 237. Page 237 in your textbooks. Number 9, they gave us a y negative 3 squared is equal to 6 times x negative 1. Now obviously this time we do have the numbers being added and subtracted from the x's and y's. Where was the vertex here in 9A from the homework, Jamie?
1, 3.
Good. Positive 1, positive 3. Which axis was the axis of symmetry, Quentin?
X-axis.
The x-axis. The focal length, Jamie?
1.5.
1.5. And then each side of the lattice rectum, Quentin? 3. The whole thing's 6, but each half is 3. So for this, for the first homework problem, we should have gone over 1 up 3. So here's my vertex. I'm going to just trace right on top of my old directrix. That's my x prime axis. And along the x prime axis, 1.5 to the focus, which means, class, we have to go backward
1.5.
to the directrix, which will come right through here, and then up and down 3 from the focus, and we'll get our parabola like that. How many have that parabola for 9A? Question?
Vertex.
Vertex, what was your vertex? 3, 1?
Mm-hmm.
Got it, okay. All right, questions. All right, let's take a look at letter C, and I'll do one more on here, and then we'll go to the other Cartesian plane. And for C, we had a y squared minus 4y plus 4 equals 4x minus 4. What did we have to do? Because it's not quite in conic form, but it's also not quite in parabolic form. It's kind of in between the two of them. Quentin, what do we need to do here?
Factor.
Okay.
Yeah. So y minus 2 squared equals 4 times x minus 1.
Right, they basically set you up where they already had the PST that needs to go binomial squared. You just need to factor out the common factor. So where is the vertex this time, Quentin?
1, 2.
1, 2. Did you catch that time?
Yeah.
Nope. Which axis is the axis of symmetry, class?
X.
The x-axis. The focal length is going to be,
1,
and each side of the lattice rectum,
2.
2. All right, so right below the other one, if you were graphing them together, right? Over 1, up 2. Another x prime axis right below the first one. Focal length is 1, so this time the directrix is going to be your y-axis, up and down 2, and a little bit of a tighter parabola this time. If you can kind of see it overlapping a little bit here with the white one. Other than the vertex being at 2, 1, Quentin, how do we do on this?
I have my vertex at 2, 2 because I went ahead and moved the 4 over to get -8.
And then you completed the square, which, well, but if you've done that though, right, if you move it over as a -4 and then you complete the square getting a +4, you would think it would have worked right back out again. Unless when you complete the square you forgot to add to both sides.
Yeah, I did.
So we had 2 mistakes there that 2 rights, 2 wrongs ended up making a really wrong. Okay, questions on this? All right, let's go to the next one then, letter E. And this time I believe, yeah, it was perfect. Well, no, it's still not quite conic form. They've done only one small thing, a couple small things for you. They already have the constant over to the side, and they'd already put the y's together. You just had to kick out the 2x. Right, so we'll kick that out, put it in the front here, so we get the y squared minus 2y, leave the gap, -2x plus the 5. In the gap, we're going to put, Quentin,
4. +4.
ooh, careful, half inch
Or
square.
+1.
+1, and so that's going to give me here a y minus 1 squared, and then right here, of course, 5 and 1 class, 6, but I've got to factor out the -2, so in parentheses, x minus 3. All right, so where should the vertex have been here, Jamie?
It should have been at 3, 1.
3, 1. All right, the axis of symmetry again, class. X-axis. One of these days they're going to give us a vertical parabola. Focal length only -1/2, and then each side of the lattice rectum -1. The whole thing is 2, but each side is 1. So our parabolas, the classwork was really wide. The first homework was a little smaller, a little narrower on the next homework problem. This one's going to be the narrowest yet. 3, 1. So still going to the first quadrant. Still using an x prime axis, going -1/2, so going backward from the vertex and forward to the directrix, up 1, down 1 to the ends of the lattice rectum, and get a much tighter parabola this time. How do we do on letter E for the
I
homework?
forgot to put the 1 on the other side, so I have 5 halves.
Okay, all right. Questions? All right, and the last one for homework was letter G. And this was a true conic form. So you had to do the whole thing yourself this time. And let's see here. We had y squared plus 4y plus, well, no, still not true conic form because the x should be before the y. But still, all right, what do we need to do here, Jamie?
We move the ax and -20 over to the other side.
To get,
-ax +20.
and of course over here we still have,
Y squared plus 4y.
this time, Quentin, what do we put in the blank?
4.
4, and put it on one side, also put it on the other side. Don't forget to add to both sides. What do we end up with here, Jamie?
Y plus 2 squared equals -8 times x minus 3.
Good, this is really a 24. Factor out the -8, get -3. Vertex, class?
3
-2.
3, -2, axis of symmetry.
X
X-axis again. Focal length,
-2.
and each side of the lattice rectum.
4.
All right, so 3, -2 coming down here this time. X prime axis. Backward 2, so another backward facing parabola, forward 2 to the directrix. Up and down 4, the ends of the lattice rectum. And again, a little bit of that wider parabola. Maybe not quite that wide. Maybe a little bit more like that. Should be our parabola for the last one. Questions on these? All right, let's do a little bit more practice still before we take this quiz. I'm a little shaken by the homework, so I think we'll get a little bit more confident with some more practice. Though I think the main thing is just remembering the x and y. I think is the biggest thing for you, and then Jamie adding to both sides. But I think it'd still be good to get some practice with this. 2 more, put these on a new graph grid, unless you already set up the new Cartesian plane for the classwork. We could probably do 3 on the same Cartesian plane without it becoming too busy. So I got just a couple of these for you to work there at your seats. Get them to the parabolic form, analyze, and graph. Questions on the first one? Had to kick out the 8y is a negative, the 3 is a positive, add a 9 to both sides to get a 12, binomial squared, factor out the negative 8. Now again, it doesn't come out quite evenly. It gives you a negative 12/8, which is negative 3/2 or negative 1/2. So what we need to do is need to come over 3x and then down 1.5 for the y, and that's our vertex. On the y-axis, non-squared variable, we need to come down 2 to the focus, up 2 to the directrix, and then out 4 in each direction for the lattice rectum. Did we get the first one?
Didn't you go up 1.5?
Yeah, when the.
I was just seeing if you were paying attention. Great job. Yes, absolutely. Just like we go positive 3 for this, we would go positive 1.5 for that. Yeah. That. All right, so up 1.5 and then down 1.5. Okay, down 2 to the focus, up 2 to the directrix, over 4, over 4, and how about that? We like that better? He likes it better. Jamie still doesn't know. Uh-oh, Jamie.
I did it wrong. I had them flipped, the negative sign flipped, so I went down. I should have gone up for the 1/2. 1/2. Like I had the way you did.
Oh, you did what I originally
Yeah.
did. So you screwed up too. Okay, lovely. I didn't even look at her paper. We just both happened to screw up and say, all right, questions on this. Don't do that on the quiz now. Take points off. Do as I say, not as I do. Oh, yesterday was bad. Algebra 2's lesson. I had at least 4 errors in the lesson. It was bad. Maybe more that we didn't catch, but we caught at least 4 mistakes. Some of them were copy errors. Some of them was just, anyway, it was bad. All right, let's take a look at the next one here. Are we done with the second one, or are we still working? She's done, he's still working. All right, so Jamie, kind of follow along, and if I screw up, catch it, huh? And here, end up with the vertex at -1, 3. Go back 2 along the x-axis to the focus, forward 2 to the directrix, and then out 4 to the ends of the lattice rectum for our parabola. We like this one?
Yeah.
Quentin likes it, Jamie likes it, I like it. Questions at all on parabolas? All right, go ahead and clear your desk then, except for a clean sheet of paper and a pencil. Clean sheet of paper and a pencil, everything else away. Clean sheet of paper, pencil, I guess calculator if you really want to. I don't know that you'll need it. Pencil, paper, optional calculator. Optional straight edge, I suppose, if you really want one of those as well. And this will be quiz 39. You're going to take the quiz on my paper. Okay, so the paper you have is simply for a cover sheet. Quiz 39. When you get your quiz, put your first and last name at the top of the paper, along with today's date, which is 4/1/22. 4/1/22, or you can say April Fool's Day, or you could say my day, or whatever you want to put for the date. First and last name at the top of the quiz, even though there's not a blank for it, there's a little bit of space up there. Write the date as well, 4/1/22, or however you want to celebrate April Fool's Day. This is not an April Fool's joke, by the way, so do make sure you do your best. You'll notice that there's 3 equations on the quiz. For each equation, you're going to analyze it. So there's a little bit of work, a little bit of space rather, for you to work under each set of 4 questions. Answer the questions off to the side of each of these or down below, okay, and then you're going to do the graph on the graph grid. Any questions before we begin? All right, you may begin.